Alright, so we're going to talk about gravity. We're going to talk about Isaac Newton's law of universal gravitation. Isaac Newton was well, of course, a former astronomer who was born on January 4th in the year 1643, and well, unfortunately, he had to die on
Like most people.
On March 31st of year 1727. So Isaac Newton's introduction to gravity would be that he first began researching gravity after watching an apple fall from a tree to the ground. It's pretty interesting. He was coming home from Czechoslovakia, apparently, back to his mother, who apparently had like some kind of illness. So he took the time to spend her last moments, well, himself with her last moments, I'm guessing. Okay, so according to Dr. David P. Stern, when the apple fell, Newton must have immediately been thinking about acceleration, and he was coming to conclusions that the apple must have been accelerated because it went from a change of zero velocity when it was hanging on the tree towards the ground. He also believes that there has to be some kind of force coming down onto the apple which could cause it to fall, therefore being gravity.
Alright, Newton's second law. According to Newton's second law, force is the name given to anything that can cause motion. Newton uses his second law to support his claim that there is some kind of force causing the apple to accelerate and thereby fall. Newton begins to think of this gravity as a universal phenomenon because anything that can happen to this apple due to the force of gravity can happen to anything else. Now, to branch off the idea of everything having mass exerting gravitational force, you could use the example of the moon and the earth, because due to its acceleration and gravitational pull, the moon is orbiting around the earth constantly.
Alright, so now that Newton has his idea of gravity and he finds his own examples, he decides to call the force by, well, the name of gravity and begins to write out the mathematical equations that would assist in supporting the claim that there has to be some kind of force, some kind of force present there that would cause any object to fall or any object to gain velocity. He writes the book called The Principia, and it's published in 1687, where he would describe principles of time, motion, universal gravitation. He also brings in many different formulas and functions that would help in creating the that would help in making the formula that we have today, which is g times m1 times m2 all divided by d squared. That is g being the gravitational constant, m1 being mass 1, object 1, m2 being mass 2 as an object 2, all divided by the centers of gravity.
Newton's law of universal gravitation had a giant impact on science as we know it. It completely changed the game on how we observe space, time, and acceleration, motion, all that, and it's so awesome.
The law of Isaac Newton's law of universal gravitation even made it possible for us to accurately predict the orbits of planets, which in fact it actually aided us in the discovery of Neptune because we had found a disturbance in the orbit of Uranus. It's very complicated how it works, but it has to do with waves and the gravitational pull coming from both objects. Anyways, in the end, we just want you guys to gain a simple understanding of how gravity works and how Isaac Newton was capable of coming up with all these laws just by observing an apple fall from a tree. And the last thing is, one small step for man is one big presentation for another. Thanks for watching. Alright, so for our presentation we had one primary source, which was a guy who used to work for NASA. His name is Dr. David P. Stern, and he excelled in mass particleization and magnetosphere.
Check him out.